welcome back to part 4 of chapter 1. Let's see if we can finish up this part in this video. If not, then there'll be a part 5. No big deal. So far, I hope you guys are learning a lot. Feel free to rewind. I mean, it's a video, so go ahead and rewind it. I don't know why I say that. Feel free to rewind. Whatever. Anyways, we're going to work on these holes right here. So let's make sure I have it saved. So this is what we have so far. We have a center line that's running down here. I like this because now if I hit line, see, everything is just, there's a midpoint along everything. And that helps so much. Because if I click on this surface and hit right click and go to align view, okay, it makes life so much easier. I can hit T for guide and just snap right to that middle point. And that's just, it helps make things so much easier. Now every part can't be done like this, but for the majority, most parts created in this world have symmetry. If you look around, I mean, even my, what the heck is this inversion table that I have, everything is symmetrical on that. I mean, I don't think there's one part in my entire house that's not symmetrical. Yeah, everything's symmetrical. I'm looking at it right now. Anyway, so let's move on before I get stuck on a tangent and distracted with random objects. So we have this center line now going along here. So let's do hole placement. 0.75 along this way and 0.707 this way. I'm going to assume that's the center, but we can't always assume that, so at least they give us the dimensions. 0.707 and 0.750, so 3/4 and 707. So I'm going to hit T, and we're going to go up along this surface, 0.707. And just for kicks and giggles, I'm going to, it is right on center. So, alright, Control Z for that one. We don't need that. And dang, I already forgot. It's a 1/4 inch, but which direction? Out that way. I mean, not a 1/4 inch, 3/4. So this way, 0.75. Click this one, 0.75. Now remember, when you move these lines, look where your inference line is. We're on the green. Don't want to hit up arrow and have something crazy, so make sure you're in the green. So, okay. Now let's find out what our holes need to be in our diameter. It looks like 2 by diameter of 1/2 inch. They're all the way through. And they're going to have a chamfer. So we're going to talk about chamfers here in a minute, but let's at least draw our hole. C for circle. Notice it's 24 sides. I like 24 sides, but if I'm going to 3D print, I want more sides. So I like to do it in groups of 12. So right now, I'm going to type in 4/8. I'm going to hit enter. Now I'm going to have a 48-sided circle. So let's talk about the first second. Actually, let's go back to E and then C for circle. I'm going to type in 12. Okay. And okay, bigger I get it. See how it's, you can see the 12 sides. It's really funky. Whenever you draw a circle, doesn't matter how many sides, always draw it along an axis like this, so that these points are along the guides, so that they're not off like this. You don't want them like that. You always want points on them. So let's go with 48 sides. Make it a little bit smoother of a circle. Okay, see now that's a lot smoother of a circle. And they're 0.5, they're 1/2 inch. That doesn't look right, because Sketchup does it in radius, not diameter. So we need to redo our thinking. That is 0.25. Okay, much better. And then if you click and hold, and click, not hold, but just click it and then drag to the right, it'll automatically stop at your last dimension. So I'm just going to click it, and to verify, bottom right corner says 0.25. Excuse me. So let's do the push-pull action. Grab this surface, click it, drag it through. You can see it through there, but hold the middle mouse button as you're still holding left click, spin around, and drag to on face. Makes a hole all the way through. Double click this one, and you've got a hole all the way through. Okay. We're almost there. So let's go ahead and delete these guides real quick. Let's go ahead and select this face, right click, align view, and then left click somewhere off so it unhighlights it. And let's talk about this chamfer. It doesn't give us a dimension for the chamfer. It's in inches, so but I'm going to assume that it's a 45-degree angle chamfer. I'm only assuming because it's not listed. If it was called out on here, then you follow the call-outs. Wait a minute. It is called out. Okay. 0.060 by 45 degrees. Perfect. I assumed correct. So let's do that. So how do we do that? We're going to use something called the offset tool. It's this one right here. We're going to click it. And then we're going to click our circle, and we're going to pull it out by 0.06 and hit enter. And then we're going to do the same thing to this one. What the heck did you just do, buddy? Okay, 0.06 and hit enter. Okay. First thing I need to do, I'm going to test something. If I click on here and I hit the up arrow, yeah, okay, that's not going to work for me. Okay, notice up is, the blue axis is 90 degrees. I'm wondering if we could rotate our axes to have the blue come straight out of this perpendicular. That would be freaking amazing if we could do that. I know we can. Give me a minute. I'm going to pause it, and I'm going to experiment. Okay, I figured it out. Right click on the red, hit move, and rotate the green 45 degrees. Now, why did I do this? I'm going to show you. Because I'm going to go to View, Edit Hidden Geometry. So right here, notice all these lines right here. We could have used one of these lines. I could have created a guide like that. I mean, that wasn't that hard. But I wanted to see if we could actually rotate the axes just to try it out, to make it a little bit easier. So what we're going to do is we're going to click on this outer ring. Nope, we're going to click on the inner ring. We're going to hit the move tool. Now notice right here it says control equals toggle copy, alt equals auto fold. That's what we want. So we're going to hold alt, okay, we're going to drag down, but notice when we try to drag, it just looks all weird and funky. So what we're going to do is hit the up arrow. And since our up arrow is the blue axis, and our blue axis is now perpendicular to that, we can make our chamfer. And remember, it was 45 degrees. So if our offset is 0.06, we need to move down 0.06. Now it's automatically snapped to it. Notice in the bottom right hand corner. So I'm going to let go, but I'm still going to type in 0.06 just because. Now what I'm going to do is I'm going to use one of these guides right here. Okay, I'm not going to use the up arrow. I'm going to show you how it's a little bit more difficult. So M, I'm going to hold Alt, and we're going to move. See, it's a little bit harder to move it along that line. So notice it says online. So I'm going to just move it once, let go, and type in 0.06 and hit enter. Did it do it? It did not. So let's control Z until that line, and now control Y to bring it back. So I'm going to click right here, again hold Alt, and we're going to move it along the line. See, it says online. I'm going to let go, and I'm typing 0.06, hit enter. Now it moved, and there is our chamfer. But notice how much easier it was to just hit the up arrow and move it. So let's get rid of that guide. What did I just erase? I felt like I just erased something else that shouldn't have been erased. Okay, we're good. Alright. So go to View, Undo, Hidden Geometry. Okay. Now we have chamfers there. So let's do the same thing here. F for offset. and we're going to click on this, and we're going to, I hate when it does that. No. Okay, look. Click on the circle. There we go. Thank you. 0.06. And then this one's going to be the same, 0.06. Okay. Now, click the move tool. Whoops, click this circle, then the move tool, then Alt, and then the up arrow to force it in that direction. Ooh, we need to rotate our camera a little bit. Okay. 0.06. Perfect. M for move. Do the same thing. Nope. Click this first, then M for move. Alt. Hit the up arrow. 0.06. Boom. Okay. Now we have our chamfers, nice and clean. So let's go ahead and click on the red axes and hit reset. Okay, now everything is reset back to normal. I'm going to put my guide back in here just in case I need it, and we're beautiful. I love it. Okay, is that the entire part? That is the entire part. We're done. That part is done. So let's verify something real quick. So I'm going to triple click. Okay, right click. I'm going to hit component or group, doesn't matter. I'm just going to call it final. Come up here, it says component. It doesn't say solid. So somewhere it's not happy. So let's click solid inspector. And it's going to say we have 6 stray edges. I'm going to click it, and it tells me, okay, we have some stray edges right here in red. They're hard to find, but if we click on X-ray view, it shows where those stray edges are. So one thing we could do is either use the eraser tool and, okay, don't erase your entire part. Try to go through. You can zoom in. Yeah, you can see it's tricky to do that, but luckily we don't have to do that. Just hit this and hit fix. Then it says no errors, everything is shiny. Go back up here, it says solid component, 23.6 meters cubed. Okay, that means we have volume. We are good. Now let's scale this down to be able to use for 3D printing. So I'm going to use the tape measure tool. I'm going to click right here on this line. Okay, and I'm going to hold control to get rid of that guide and make sure hit up arrow. Okay, and we're going to get it right connected to the origin and click once. And then you're going to type in 4.00 and then hit the quotation marks for inches. And it says, do you want to resize model? Hit yes. Control Shift E, zoom extents, window, model info, switch this to inches, close it, and let's just confirm that this to here is 1 inch. 1 inch. Perfect. This down to here is 4 inches. This is why guides are important. And then from here to here is 3.5. So everything is now to scale. We're going to click it. 23.6 inches cubed instead of 23.6 meters. So let's talk about, in the last few minutes before we do some rendering, one last thing. Why do we care about our volume? You guys are engineers, you design parts, so if you know the volume, what can we find? We have a fancy equation. Hopefully you learned it in your physics class, even your first year chemistry class, that density is equal to mass over volume. So if we know the volume and we know what our material is made of, such as aluminum, we can find its density from a density chart, determine the mass, and then determine the cost. Now, some programs have the ability to do mass evaluation, and it tells you everything about the part. Sketchup doesn't have that. However, I have made a Excel file that does everything for you on that. So I'm going to show you that. Okay, so here is my fancy little calculator. It's made in Excel, but I don't have Excel on this laptop. I'm using LibreOffice, so it's missing a little graphic that says pick your material, input your volume, and find the mass. So let's make our part out of, let's just go steel. No, I want 6061 T6 because that's the coolest name of aluminum you could ever have. Aluminum 6061 T6. Okay, our volume was 23.6 inches. Oh crap, I forgot. Notice this is volume in meters cubed. So let's go over here, input in inches cubed. Okay, and it will give us meters cubed, 23.6. Hit enter. So this is our new value right here. Oh crap, don't do that. Don't do that. Okay, I just want the number. I hate when programs do this. Okay, 00386. I'm just going to round it off. So let's just highlight this and just go 0.0000386 735. Okay, our mass is 1.05 kilograms. So now we can calculate the cost. So this is how I do my mass evaluation. I have charts in here. Actually, all right here. Like here's where it pulls. Certain things from, and whatnot. So yeah, pretty interesting. So let's go ahead and close that. No, I'm not going to save. So that is my mass calculator. So we know this is about a kilogram. So perfect. If we needed to shave off some material, we could do some rounds along here. We could also maybe felt confident. Let's see. Getting rid of too much strength, maybe shrink down a little bit. But anyway, that's how you do mass evaluation with SketchUp. It's not as nifty as other programs that automatically do it, but I'd love to be able to program an extension that will do it. But for right now, that Excel sheet is perfect. Okay, so anyways, some tips and tricks in there. Remember to rotate the axes, to have the blue axis perpendicular to this face to make those chamfers, and it'll be good to go. So thank you for watching this one. In the last video, part 5, we're going to talk about rendering. So let's go ahead and stop here, and then we'll begin the next one shortly.